Hi everyone, this video is going to be kind of an introduction to triangle congruence, along with using side, side, side and side, angle, side to prove that triangles are congruent. And so let's look first of all, to know triangles are congruent, we need to know that every side and angle are congruent to each other, or that is what it implies. So let's just say I should have drawn this one first, but that's okay. Let's say I have a couple triangles here. All right, so if these are my two triangles, and I know this side is congruent to this side, and I know this side's congruent to this side, and I know this side is congruent to this side, and this angle and this angle, and these angles and these angles are congruent, then I know that this triangle is congruent. These two triangles are congruent because every side and every angle are congruent. And this, we'll just label this A, B, C, D, E, F. And so we can say triangle ABC is congruent to D, E, F, and you have to go in the right order. So if I start with B and I go B, C, A, I have to go E, F, D. So be really careful on how you label things. They have to, for congruence, they have to be in the right order. So I could say these two triangles are congruent, but that's a lot of information you would have to find to prove. You'd have to find every single side is congruent and every angle. So these congruents that we're going to go over are like ways to use less information. So for example, this side, side, side idea that we're going to look at first, we call SSS because we're kind of lazy and we don't want to write out side, side, side. We know if we have three sides, we can only make one triangle with those three sides. You've done it in your construction homework. If you actually did your construction homework with, let's say, one of these and a straight edge. A lot of people guessed. So your construction homework, you did three sides of a triangle, and you can only make one triangle. So if I know two triangles all have equal sides, we can actually just say these triangles are congruent. And the same thing with the SAS, the side, angle, side, and there's more that we'll learn as we go through this chapter. So let's look at side, 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 and make sure we understand the theorem for this. So I'm going to cheat and use this little piece here. Maybe I'll make it look the same for this one. That's fine. I like them to kind of be moved around and look a little different because that's kind of the trick of finding these. So let's say that we know this side is congruent to this side, and this side is congruent to this side, and this one's congruent to this one. Then we can say these two triangles are congruent by side, side, side. So that's kind of what the theorem looks like. So then the two triangles are congruent. All right, so let's do one proof using the side, side, side. So let's say I'm given LM is congruent to NP, and I know LP is congruent to NM, and I have the following drawing. I just flung one of my pieces on the floor. All right, so if I have the following drawing of two triangles, this side's N, this one's M, this one's L, this one's P. I know this one, and I know this one, and this one, and this one. So here's what I'm given. How can I prove that these are congruent triangles? Well, we know these two are congruent, these two sides and these two sides. We're given that. How can we prove LN is congruent on both triangles? Well, it's the same line, right? So we use the reflexive property to say, well, if it's the same thing, they're congruent. So here's where I'm going to go with this. I'm going to do a flowchart proof, and I'm going to say, well, LN is congruent to LN because of, here's my little box, reflexive. property of congruence. And we know the next little sides would be maybe LM is congruent to NP. So LM and NP are congruent, and they are congruent because we are given that information. And the last little one here that we have is that LP and MN are congruent. Maybe I'll go PL because I wrote it wrong, and MN are congruent by given. So what do we have? And we have a side, and a side, and I purposely wrote them this way. And we could say, all right, so they all three lead to triangle. LMN is congruent to, well, if I go LMN, then I have to go NPL, because you notice these two sides are congruent, right? So if I look, L is going to match with N, and M is going to match with P, and L matches with N. Oops. Yeah, did I do two L, M, N? Oops, I didn't mean to do, no. Did I do two N's? No, I see what I'm doing. I confused myself. If I go L, M, N, I go N, P, L. Suddenly, I forgot my little triangle symbol, but I was suddenly thinking I was doing something wrong, but they both have some of the same letters in them, so it just threw me off. Okay, so we had three sides, and we said why each side was congruent, and it led to congruence. So I really like the flowchart proofs for a lot of these. There is a lot of what we call two-column proofs, and I think this kind of shows you more of, for this, it works better in the proofs this way. All right, so the next thing that we're going to look at is side angle side. And what you need to realize about side angle side, SAS, side angle side, is the angle has to be in between those two sides. So what does that look like on a triangle? I'm going to be lazy and just draw some without a ruler, so they're not going to look very good. Oops. I'm usually a perfectionist. That's okay. So side angle side, side angle side. That's what it's going to look like. That angle has to be between the two sides. Has to be. So think about this. We have all these symbols with S's and A's, right? And we cannot spell a bad word because that's bad. So you have to think about making sure you never go angle side side or side side angle. So all of our theorems, you will notice, can't spell that bad word. So we have side angle side that we're going to deal with on this one. And so if we see those, then we know that they are congruent. So let's use this in a proof as well. And I am going to use my ruler, so I'm going to prove triangle AMC is congruent to triangle MBD, and you're going to be given that AB is perpendicular to CM, and that AB is perpendicular to DB, and that CM is congruent to DB, and of course I haven't drawn any of these yet to show you what, and M is midpoint. Okay, so here's what my drawing is going to look like. Kind of going a little bit into my word midpoint. That's okay. Okay, so A, M, B, and D, and C. So what are we given and what are we proving? So here's our drawing, and we were given that AB is perpendicular to CM. So look, AB is perpendicular to CM. That means this one has to be a 90-degree angle. That's the definition of perpendicular. And then we know AB is also perpendicular to DB. So this one also has to be 90-degree angle. And then we know CM and DB are congruent. So CM and DB, those sides are congruent. And we know this is the midpoint. What does a midpoint do to this side AB? Is midpoint of AB is what I should have on there. So what does a midpoint do? It cuts it in half, which means this side has to be congruent to this side. So what do we have for our congruence? We have side, angle, side, side, angle, side. Now let's write that out and prove or show our proof. So we would say, okay, well, we know AM is congruent to MB, and why are they congruent? By the definition of a midpoint. Okay, so those are congruent. And then the next thing that we know is we know angle B and angle M are congruent. We kind of got to label those a little bit better. So we're going to call them angles DBM. DBM is congruent to angle CMA. And these two angles are congruent by the definition of a 90-degree angle. By the definition of a 90-degree angle, or the definition of right angles, something in that way there. And then the last one is that DB is congruent to CM, and we were given this information. And these all three lead to a side, angle, side, and that triangle AMC is congruent to MBD. Congruent to MBD. And I forgot the little triangle symbol again on that one. Oops. And you can't see it. So, whoop. Those two are congruent. Now I went AMC, so I have to go MBA or MBD. So you have to be careful that you go in the exact order, and this would have a little thing around it just because that's what we're showing, and then the Y is next to them. So again, I like this kind of proof of here's the three things, and I went in order: side, and then an angle, then a side, and they're proved by side, angle, side. So those are some examples of a couple proofs. The next thing I want to show you is just some examples, and tell me, can you prove these? So I already drew these ones out, so they're a little, don't have to wait for me to draw anything. So can you prove these two triangles congruent? And if you can, how? So let's look. We have a side, an angle, and a side. Can we prove those two are congruent with that given information? Yeah, by side, angle, side. All right, here's the next one. Definitely look congruent, but that's tricky. We have a side, and a side, and a side. Do we have enough information to tell whether or not this is congruent? Nope. We need another something. Yeah, we need an angle or another side. Angle in between or a side. So no, you cannot tell that that one is congruent. Not enough information. What about this one? And these little arches, right, mean that those two angles are congruent. Or I could have said this line is going to be the midpoint of that angle, so that's showing those are somehow to say those angles are congruent. Could I prove these two triangles congruent? Yeah. Side, angle, side, side, angle, side, because that's the same side. We use that reflexive property. Okay, this last one, I had to give you a little more information. Can you prove these congruent if I tell you AE and BD bisect each other? So AE and BD bisect each other. What does that bisect tell you? Well, it tells you that AE, if you're going to bisects, and this one equals this one because it cuts it in half. Same with this one here, is it's cutting BD in half as well. So now we have two sides. Do we have another side or do we have another angle? Well, we can prove this angle is congruent to this angle by vertical angles. We know vertical angles are congruent. So this one you can prove. Some of these are going to make you think and make you realize, like, well, how are they congruent? Again, the bookwork or in Math Excel kind of helps you. It leads you towards the right answer in a lot of multiple choice. So you must try some of your proofs in your book, your workbook, to really understand this section. And it's not like I mean, triangles are used a lot in building and everything, and it's a good lesson um, for really trying to figure something out without just being given information, like using what you know about triangles or sides and all the different theorems we've been going over and using those to come up with a conclusion. So make sure you do some of those proofs in your book.